My name is Corinne Donnay from the Functional Advanced Neuroimaging Lab at UC Davis. This abstract is looking at perfusion and free water in the Penumbra region of white matter hyperintensities. White matter hyperintensities can be identified on fluid attenuated inversion recovery images as these hyperintense regions within the white matter. They are very common in the elderly population and are associated with vascular risk factors, motor impairment, as well as an increased probability of stroke and cognitive impairment. Our collaborators have previously shown that the area surrounding white matter hyperintensities, or the penumbra, has reduced white matter integrity. So we asked the following questions. The first was how perfusion and free water content in the penumbra region compares to the normal appearing white matter. Then we asked how these biomarkers changed in the lesion core compared to the penumbra. We used a single delay pulsed arterial spin labeling sequence to measure perfusion. We had 120 label and control images to start with and removed volumes that were corrupted by motion. Then we implemented surround subtraction and created perfusion maps using FSL. Free water is a DTI-derived measure of water molecules that do not experience flow. The diffusion weighted data was collected in 30 gradient directions and with a B value of 1,000. White matter hyperintensities were acquired from a FLAIR sequence and segmented using an in-house semi-automated procedure. For each participant, we registered our perfusion and free water maps to the same space. Then we split the white matter hyperintensities to spatially separate lesions. For each cluster, we dilated the lesion to create 4 layers of the penumbra within the white matter. The rest of the white matter that did not make up any of these layers were classified as normal appearing white matter. This left us with the mean values of perfusion and free water in the normal appearing white matter, the lesion core, and all of these layers. We had a total of 295 participants that were cognitively normal, had MCI, or dementia. Here we compared the perfusion values of normal appearing white matter to the white matter hyperintensity core and each of the layers. Using a mixed effects model, we found significant decrease in the perfusion of the lesion core and all of the layers compared to the normal appearing white matter. As you move further away from the lesion core, the CBF increased. I would also like to note that all the models controlled for lesion size, age, and participant. Individual white matter hyperintensity was also a nested random effect, as participants may have contributed multiple white matter hyperintensities. The white matter hyperintensity core was significantly different compared to all of the layers. Interestingly, we did see this dip in CBF values. The rest of the layers had higher mean CBF values. For free water content, we found an opposite trend. The white matter hyperintensity core and layers 1 and 2 had higher free water content than the normal appearing white matter. However, layers 3 and 4 had lower free water content. As we would expect, compared to the white matter hyperintensity core, all the surrounding layers showed decreased free water content. To summarize, the study looked at perfusion and free water content surrounding white matter hyperintensities on an individual lesion level analysis. We showed that the perfusion decreases and free water increases in the penumbra region of white matter hyperintensities. This suggests that white matter hyperintensities may be the tip of the iceberg of a broader physiological disruption, and that the region around white matter hyperintensities is vulnerable. Moving forward, we will add information about where the lesions are located. 2 key limitations were that we used single delay pulsed ASL data, and given the low image resolution of free water and perfusion maps, voxels close to tissue boundaries are susceptible to partial volume effects. I would like to thank the FAN Lab, the IDEA Lab, and the grant that made this research possible.